So if you head down to the resources section, there's a file there called fpm_type. So you can go and open that up and click on the test cell here. Now you'll notice here that I've added in 4 extra flags, and I've added these in order to allow us to debug the multiplier and see and make sure it's actually working properly. So this tells us that we're going to have a normal input times a normal input, and will give us a normal output. Normal times a subnormal will give us a subnormal. Normal times a subnormal gives us a normal, and normal times a normal will give us a subnormal. But remember, these here can be swapped round the other way, so it could be the x is the normal and the y is the subnormal, or the x is the subnormal and the y is the normal. So we've got to take care of that. So I'll show you how we do that just now. So let's head back into the top level here. So the extra circuitry is in this little block here. So let's drop in, and you can see I've added the circuitry here. Now this is relatively straightforward. I'll just shove this up a wee bit. It's relatively straightforward. What I've done is I have noted that here is the inputs. Okay, so this tells you whether the inputs are normal or subnormal. So you'll get a 1 would give you a normal, and 0 would give you a subnormal for your x and your y. And then the output here works the other way round about. You'll get a 1 would be a subnormal, and 0 would be a normal. So I've wrote out a little truth table. If I zoom out, you'll be able to see it. So there's a little truth table here, and we've got our 3 inputs. We've got our xn, yn, and our we've got our xn, yn, and we've got our output, which is our sub. So that's these here. So we can write these out, and I've just put all the combinations. So we've got 8 different combinations, and I just wrote down what the combinations mean. So for example, if you take the first one here, we've got 0, 0, 0. So what we're saying is x is a 0, y is a 0. So whenever x is a 0, it's going to be subnormal. And when y is a 0, it would be subnormal as well. And whenever this sub is 0, you can see that sub was a 0, then it would be a normal output. But we're not really bothered about this output here, because this is going to be subnormal times subnormal. And when we multiply these two together, it would just tend towards a value of 0. So it would just underflow to 0. So I've just put a cross here because we're not catering for this, so we don't care about that. And the same with this one here, because it's subnormal times subnormal, we don't cater for that. So let's just pick another one just to work through. So say the last one here is 1, 1, 1. So 1, 1, 1 would be a normal times a normal, and the 1 would give us a subnormal. So that would be normal times normal giving a subnormal. But we're only going to have 4 output types. Okay, so we've got rid of 2 of them so far, so that's us left with 6 here. But there's a couple of them get repeated. And you can see here, if we just pick this one as an example, we'll just go through this one. It'd be n times ns will give us an s, so it's nss. So we would have the value of nss here. That's one of them, so that would be 1, 0 and 1. So, but you could also have it round the other way. You could have the this value here, could be the s and that could be the n. So we've got this up here. So it means we've got this one here and this one here. So in order to create this one here, we're going to have an inverter on the x, and we can leave the y in the sub as is, and that would give us a high output. And again, we could look at this one here, and we could leave the x and also the sub the same, so that's the x and the sub the same, and we would have to invert the y input. Okay, and this would give us a normal times a subnormal given a subnormal. Now you could go through the same for this one here, and you're going to have do another 2, and this one and this one. So now we take these outputs, and remember, we don't want these outputs to go high whenever we've got any form of special value coming in. We only want these to go high whenever we work through a normal times a subnormal number through the whole multiplier. So let's go up and we'll see where these go to. So we take the outputs here, and then we put them into the special cases. So that's the input for the special cases. I'll zoom in a bit again so we can see it. So that's the outputs here, and this is the inputs to the special cases. So it comes out here and in here. So when we go into the special cases, this is the input here, and we put them into the multiplex section. So they come in through the multiplex here. And again, I'll zoom out a little bit so you can see this here. It's a bit smallish, but these are the 4 inputs here. And we're doing the same as we did with the previous output here when we did this not exact. We don't want there to be any output here. That is, we don't want to flag anything if any of the special values go high. So if any of these special values go high, this line here would go low, and the AND gate would prevent any output passing through. But if all of these were to go low, which is what we have at the moment, then we would have no special value coming in. This would go high, and this is allowing this point here to now pass through to the output. So it was relatively straightforward. We've seen that before whenever we looked at this non-exact value and also these other ones here. So let's head up to the top level. We take out these outputs here, and we'll head up here. I'll zoom in a bit so we can get in again. So we come back out of this multiplex here, so we come back out in these pins here, and then these go to the next level up, which is our top level here, and these are the outputs, and these outputs get taken right up to the top level, which will come out here, and then they head from these tunnels here over these tunnels, and we've got the final output here. And you can see that it's actually, I've got a value in there, and you can see that this value here must be a normal times a subnormal, giving a normal result. But it doesn't actually tell you here which one of these two is the normal and the subnormal input. We just know one of them is a normal and one's a subnormal, so that's all we need to know for the moment. And it's enough information for us to help us to test the multiplier and make sure it's working properly. So that's all there is for this video. I'll get you on the next video. Goodbye.